G'day everybody, it's Damo from Twist Landscape. How are you? Hope this presentation finds you well. Just taking a little bit of time out today to talk about some of the principles of the construction techniques that we use while doing boulder walls to turn your average sort of load of boulders that look like this into a formal structure that is retained. Because we can't edit, we're doing a one-shot wonder. Alright, here we have a scale drawing of a 2 metre wall, okay, and I've got this green line which denotes centre line. Alright, and this will be able to get some sort of scale on the angles that we're talking about. The principles of building a boulder wall. Firstly, depending on the ground, we will dig our trench out, okay, as per the engineer's spec. Alright, once we dig the trench out, and it'll look something like this as a side profile, we'll do the heel, okay, or the back slope or rake, whatever you'd like to call it, and then that there is ready to receive our rocks. Alright, so it's pretty simple, okay. Now, if we have a look at essentially the setup, this is our natural cut, okay, that's the end of natural ground, alright, and that's on a slight back slope, okay. We then go over to these rocks, okay, through our pile. Now, as you can see, when we look through these rocks, okay, there's no shapes that come in an acute angle, all right? They're very erratic, lumps and bumps, and essentially like big potatoes, all right? These rocks are the ones that we've been using for the last decade, all right, on the coast, out of Hanson at Glasshouse. Now, to get these into a formal, clean fashion, which locks the wall in, we have to do a few things. In this instance, okay, 50% of the height of the wall, all right, we've got a metre footing. This rock here, an average rock denotes around about 700 to 800 mil, all right? So what we do with the digger at the back, we grab the rock, the digger, and that comes down into our trench, okay? Now, as you can see, we don't have the luxury of having these particular shapes. In fact, over the last 20 truckloads that we've had delivered on this job, that's right, 20 truckloads, we're doing about 400 squares here, there's no rocks that come shaped like this, so we need to work with what we get. So, let's say we have a rock, we put it in, like so, okay, and that's sitting quite nice, and we've got some good embedment because of the shape of the rock, but essentially what we have to do then is kick that rock back to our 1 and 4, okay? So once we kick that rock back to our 1 and 4, that allows us to get the engineered rake, whether it be 1 and 4 or 1 and 3, okay? 70% of the time, when we get the vertical face, and we tip that back on the 1 and 3 or the 1 and 4, all right, the front edge of that rock will kick up, okay? It's the law of physics, we can't just do it any other way. However, we've got this beautiful embedment on pretty much 80% of the rock at the desired spec, okay? So, once again, to reiterate, we grab our rock, we come into the trench, and then we go back to the specified back slope, okay? In this case, we're going for the 1 and 4, and I'll explain that later. Now, once we've got our specified back slope on the rake of the wall, we've got this embedment here, and generally, as I said, because of the shapes of the rocks, they will always kick the front up. There's no other way to do it, okay? We're building boulder walls, not block walls, not sandstone block walls, boulder walls. What we then do is we load all this with 4075, okay? So let's say that this whole system here is all 4075. We have our nice geocloth wrapped up as per this here, okay? So the geocloth's wrapped up on top, and then we create this beautiful sealed system of rock, 4075 geocloth, and a nice porous wall, okay? We generally leave a pillow just above here like so, okay, of rock, and it enables us to nestle in the next rock, okay? So once again, we come in and we're holding our rock up in the air, like so, and then we need to find that back slope, which is found with the string lines, and that enables us to get this nice face, right? Now, this face is important on a few aspects. It's not just an engineering aspect, but the tighter that face is, as per that picture that you just saw, the neater that everything locks in. So structurally, it gives us this good, strong honeycomb structure where everything ties in. So it's very important, okay, on the 1 and 3. Now, what I want to point out to you, and I'll talk about this in greater depth, okay, the reason why we have always built our walls at 1 and 4, all right, is quite simply if you have a look at this rock here, we've come in and put it on the 1 and 4 rake, okay? Now, let's just give you an example on what that would look like if I went back to 1 and 3, all the way back here, okay? That's 1 and 3, all right? Now, the problem with this 1 and 3 rake, okay, just to highlight this, is we simply have a top load over the gravel as we come back through, okay? So by the time we get to the top, we've got a lot of the weight of this wall not centralized over the mass of the rocks themselves, okay? When we come back to the 1 and 4, okay, the rocks sit nicely on themselves. They don't want to kick forward. When we come back to the 1 and 3, we find the rocks wanting to kick forward, kick out like so. And it also enables us to bring the center gravity of the wall straight through the middle of that structure, okay? So they nestle in, and it allows us to bring that gravity or that load, all right, straight through the center of the structure. Remembering that our natural ground's here, so we'll build these rocks all the way to the top. This will be gravel all the way here to display some of that load, and then we can backfill, all right? And that means the major angle of repose or any surcharge is coming through this area here, okay? So we've found with the 12,000 square meters of rock walls that we've done, that this works perfectly for the rocks to sit naturally on themselves, okay? Now, the other thing to remember when we're building these walls is we have a lot of machines, okay? So you've just got to be mindful that as these machines come in, okay, this beautiful little natural ground that we have, that'll get minced up. So that's a scale drawing of a bobcat tyre, all right, and he's coming in there feeding gravel over the back, all right, and over the duration of the job, this is going to get minced up a bit, all right, so it's hard to keep it as natural ground. It's literally impossible, all right. So as I said, that's coming in, working, putting the gravel over to the top, all right. Now, the main thing with the embedment, okay, and as we talk about the embedment, is you potentially won't have the embedment 60% of the time on that front edge of the rock, okay? But that's not the crucial thing to us. The most important thing is the main body of the rock, okay? So we call it the bum. Where the rock wants to sit naturally is nestled into this ground, okay? If there's any undulation in that coming up, that gravel comes in, we tamper that down, and that locks the base course in. Remembering, we use the largest rocks available on the bottom, and then we scale up to the top. So these big bundis go on the bottom, all right, hence a gravity wall, okay? And then that all locks in nicely, all right? So that's the important thing about that, all right? Now, just talking about the embedment while we've got you, okay? It's crucial that we have the appropriate embedment, because that there, as I said, displaces this load down through the planet, okay? As opposed to everyone talking about this little kick here, all right? If we have a look at the surcharge, all right, that kick's actually coming closer through the center of the wall, hence why this width is important, okay? This here, once we have this wall and that download central over that structure, okay, all that weight wants to come through here, okay? Hence why we're in a nice embedment and we're pushing back through the planet, okay? We're pushing back through the planet. 9 times out of 10, we could expose this and this wall's still going to be secure purely because of this simple heel, okay? That rake at 1 and 4. Now here's a demonstration of that particular heel, which is actually still on site, okay? As you can see, that rock is still on site. This is natural ground level that was cut down. That's 900 at that point, okay? We have about 370 mil from natural ground to the bottom of that rock, which is sitting in here. Then we also have another 250 mil over the level, all right? And that goes back another 200. So when I shot the screed from here to here, which we have a photo of, we've got a 600 embedment, okay? 600 embedment, and this is exactly what we're talking about here. Now that's a side profile. That's not a front profile of the rock, it's a side profile, which allows you to get some sort of grade of how we've dug that footing out. And that there will be on a plane all the way through, because this was the deepest part of the wall, okay? So that's important to realize when you have a look at the embedment, all right? That's the end of the first part of my presentation. Thank you.